Greetings, everyone. I'm Patrick Veazie with NC State University, and today we're going to be focusing on magnesium fertility. So, why is magnesium important? Magnesium is one of the essential elements that plants need to be able to reproduce and to grow proficiently, and it will not be able to complete its life cycle without it. In the case of magnesium, it's the central atom of the chlorophyll molecule, so it's very important in terms of photosynthesis. And a lot of our deficiencies occur later in the production cycle, right about the point of sale. So growers really need to be aware of this to prevent those late season nutrient deficiencies. So there are three common sources of magnesium: dolomitic limestone, which is in your substrate, your irrigation water, and your fertilizer. We'll take a deeper dive into each of these. So dolomitic limestone being that first common source of magnesium. So a lot of your substrates, especially peat-based substrates, include dolomitic lime to raise that pH up to that 5.8 to 6.2 desired target range. And we'll see that the reactive lime brings it up, but then there's often that residual limestone that lingers within the substrate that's not actually being used. Now, a lot of this is going to run out later in the production cycle. So especially us here in the Southeast, where we don't have alkaline waters here in North Carolina, you'll run out of this, and if you're not supplying your own magnesium, we will see late season nutrient deficiencies occurring. So back to irrigation water. So there are a lot of places in the United States where there's high alkalinity, and there's enough magnesium in your irrigation water that you can avoid nutrient deficiencies throughout the season and not need to supply your own. However, growers should conduct water tests in order to determine how much alkalinity is in their water to understand if it's needed to be supplied. So especially here in the Southeast where we're low alkalinity, we'd need to supply it, but growers in that upper Midwest likely do not need to, but water analysis is essential. And then fertilizers. So some fertilizers like this 15-5-15 can supply enough magnesium, such as shown here on the bag, which is 2% soluble magnesium. And then compare to this 20-10-20 where it's supplied, but it's in very low percentages, not enough for that crop to make it through the season. So then we go on to diagnosing nutrient magnesium deficiencies. So the common symptoms are going to be intraveinal chlorosis of the lower foliage, in severe cases, entire leaf necrosis. So it's shown here on that begonia. It's on that lower foliage. It's not going to be on that new growth. It's going to be on that old, fully expanded leaves because that plant's moving it up into that new growth to sustain the new growth. Shown here on the gerbera, you can see that intraveinal chlorosis occurring on that older leaves in that rosette while the new growth looks nice and healthy. Shown here on the tomato, we see that intraveinal purpling occurring, which is common. And then as well, shown here on the right, where it starts as that intraveinal chlorosis and then can move to entire leaf chlorosis in severe cases. Now, what are the mimics for magnesium deficiency that may be confused? Potassium can exhibit the very same intraveinal chlorosis on the lower foliage, but generally potassium deficiency will manifest sooner and earlier in that production cycle if it's not supplied. Iron, on the other hand, is going to occur on that upper foliage. So looking at that petunia here, we can see that it's occurring on the new growth, and all of that old growth is nice and healthy. This is that differing mechanism between diagnosing magnesium and iron. However, conducting a leaf tissue analysis to confirm is always a good idea to determine exactly which element is deficient. So magnesium rates for most crops, 25 to 50 part per million through a CalMag fertilizer is going to be more than enough. And then in case of corrective procedures, 2 pounds per 100 gallons of magnesium sulfate, Epsom salts, and then as a preventative, 1 pound per 100 gallons of water will prevent most of your problems on a monthly basis. So kind of what are our take-homes and takeaways from this today? So maintaining optimal magnesium concentrations within the plant is important to promoting plant growth. And then magnesium can be obtained through a variety of ways, ranging from your water, your substrate, or your fertilizer. So understanding that magnesium level of all three to help promote plant growth and to make sure you're supplying enough. Then your two mimics are going to be potassium and iron. They can both manifest very similar symptoms to magnesium deficiency, but that location and timing are important to visual diagnostics. With that, I'd like to thank everyone for attending today. And e-GRO has a lot of excellent resources, more on magnesium fertility and diagnostics as well. Thank you.